My name is Xavier Lobao, and it is a pleasure for me to be here in front of you. I'm going to take you on a trip to space, and it might sound a bit strange, but I'm hoping throughout my presentation to be able to convince you that space is very relevant in the scope of the future IoT spectrum of solutions. As I said, my name is Xavier Lobao. I work for the European Space Agency. I have been working there in the last 25 years, and always focused in the area of connectivity. And my responsibility there is the preparation of the future for telecommunications in the European space programs. And there I go from trying to understand what is going on, trying to glance into the future through reading tea leaves, looking into the crystal ball, and so on and so forth, and translate that into meaningful technology and innovation development. The European Space Agency in the area of telecom is an innovation agency, so we basically do R&D. And as I said, I have been long enough. I have witnessed satellite from being a very niche technology, of kind of say last resort solution for connectivity when nothing else would work, into something that I quote there is becoming mainstream. And I put there a number of illustrations of that fact that satellite communications is becoming mainstream. You all know about the development of constellations in low Earth orbit, of satellites. We are also looking into from the public sector for sovereignty, secure connectivity for governments and institutions in Europe and as well as elsewhere in the world. We see big multinational corporations interested in becoming satellite operators, and I will come with an illustration. We have mobile network operators also investing into space, and we see new players, and of course, I mean, this is something that everybody knows. Elon Musk and SpaceX and Starlink, a big disruption introduced. We are very happy about the disruption that was introduced by Starlink into the market, and is challenging the establishment, the established players. I have a couple of words for what I call the new elephants in the room. We have Amazon. Already a couple of weeks ago, launching the first batch of satellites into orbit to develop what is a new constellation that they call Project Kuiper. That is maybe with a different business model together, knowing Amazon and the focus into customer and customer services. And of course, at the other side, in the Far East, China is doing a significant amount of developments in public initiatives, but also private funded initiatives. Very remarkable to me is that a company like Geely, that is basically a car manufacturer, is setting up a constellation of satellites to provide broadband connectivity and to provide navigation, thinking probably of the connected and the autonomous cars of the future. So it's fascinating what is happening. For somebody that has been quite some time, is a very interesting moment that we are living. It's always good to talk a little bit about the money. And on the money side, you see there on the top, basically on this pie chart, what is today the revenues generated by satellite communications is short of 160 billion euros per year. Out of which, of course, I mean, there is a breakdown into satellites and applications and so on and so forth. What is more significant is that this is growing. It is growing, but I put there the bigger cube there. This is the global telecommunication revenues. So I mean, 160 billion is the revenues of satellite telecommunications, with a global telecom revenue of short of $3 trillion, 2.6 something billion dollars. So we are a niche, we are small, but there are a couple of things that I want to highlight. I mentioned Amazon. Amazon has invested so far around $10 billion into deploying satellite infrastructure. Apple has invested $1.5 billion through investment into a satellite operator, manufacturer, Global Star. And this is very significant. And then we have mobile network operators investing into space capability. With that, our projection is that, as I said in the title, Satcom is becoming mainstream. We are getting into the bigger picture. We are part of the bigger picture. And I mean, for you as a community interested in IoT, this is definitely one of the dimensions of that. Now, I mentioned that ESA is an innovation agency. We do research and development and innovation in broad terms. And all these are elements that we are investing into, that we are putting effort into, that we see as dimensions of the evolution of connectivity in the future. Obviously, it's ubiquitous connectivity, and I will dwell into that for a few minutes, but it's also about security, it's about resilience. These are key attributes moving into the future. There is a trend towards higher data rates, which takes us to optical and quantum technologies. I will just briefly mention with one slide what we are doing there. There is a lot of innovation in terms of critical technologies. We see bigger and bigger satellites and new ways of building satellites, and we are investing into that. And closer to the 5G, 6G domain, there is the integration, seamless integration between terrestrial and non-terrestrial networks. I will dwell into that in details. Direct-to-device is the talk of the moment, and it is the key development in terms of breakthrough technologies, and I will spend a few minutes on that. I mentioned constellations. In the past, when I started, it was all geostationary satellites, one satellite big, concentrated with a lot of capacity. Now everybody talks about thousands of satellites. We are not shy in thousands or tens of thousands, even hundreds of thousands of satellites is something that is today being not only talked about, but planned and developed practically. We, as an industry that is maturing, of course, industrialization so that we can reach price points that are compatible with the mainstream is something that is a key effort. And of course, I mean, when we talk about connectivity, in particular for mobility, what is important is that it's mobility everywhere. It's not just ourselves as a consumers with our devices, it's our vehicles on land, on air, and sea. And we are putting efforts into that. And something that is key, and I think in this forum, everybody is kind of an expert of the topic. No, there is no connectivity without a spectrum. So, I mean, the sustainability of a spectrum is something that we are definitely putting some effort on. We translate the effort of the European Space Agency in connectivity in what we call 6 interconnected pillars. I'm not going to dwell too much into that, but just for you to understand that we have a structured kind of a strategy with these 6 pillars: mobile convergence, the competitiveness of the industrial solution, spectrum sustainability, as I said, is a key focus area. We are interested in ensuring resilient connectivity, in particular for governments and institutions. We are, for many years, already developing optical and communication technologies. And last but not least, I think I will end up with a slide on that, is the future of even beyond Earth connectivity into the interplanetary connectivity, what we call the Internet of the solar system. Right. I will focus most of the time in the presentation on the mobile convergence. And here, I mean, some elements were already mentioned. Direct-to-device, I will explain an initiative that we are taking with an open laboratory in space that I think is quite significant. Standardization for us in the European Space Agency is key. There are, of course, proprietary solutions, very successful in delivering services. We believe in our, say, European, or from our European perspective, in open standards as a sort of diversity, opportunities for competition, among different solution providers and a continuous push for innovation, which is something that is beneficiary for the users and is beneficiary also for the market in general. Of course, I mean, there are a number of elements that I will not dwell into too many details, like artificial intelligence, of course, is a key topic, sustainability in general, green in the use of energy, and so on. Trends like joint communication and sensing is something that we are looking into, but I'm not going to dwell in that in this presentation. And of course, extended reality, in particular on the industrial environment, is something that we look into. Now, I'm going to, since my role is on the future, I will concentrate a bit on the future. The future where we are putting effort is 6G. And in 6G, the vision that I think we share with some organizations is still in the early stages of definition, is that 6G, as a minimum to me, is a network of convergences. Convergences in the sense of convergence of the telecommunication technologies and solutions and networks, fixed, mobile, terrestrial, and non-terrestrial, including aerial. It is also a convergence of connectivity or communication and computing, with edge computing and the likes. It is also a convergence between the physical and the digital world, with things like digital twins, metaverse, that is not so much fashionable these days, but still, I mean, there is a convergence also in the sense of bringing into the digital domain things that are in the physical space. The translation that we make of that is that to deliver a vision, this vision of 6G, we need what I call the 3D networks. Networks on the ground, basically cellular, networks in space, and maybe networks also in the intermediate layers, air, drones and so on, but also a stratosphere, with the stratospheric platforms. This is what I call the 3D network, and it is fundamental to combine all these layers in order to deliver on the promises of a converged network. Some vision you see on the bottom left right-hand side, this diagram. Some people talk about an evolution from separate networks that we had up to 4G. In 5G, we had integrated networks. So, I mean, we could, with the non-terrestrial networks in the 3GPP standard for 5G, there was a recognition of an interworking between terrestrial and non-terrestrial networks. As we are moving towards 6G, there is a talk about unified networks. And this is something that I believe in, and that's why we are putting effort in developing, putting the means to work for the benefit of the ecosystem, to make sure that we achieve this unified network from day one. Last month, or 2 months ago, last month, there was the kickoff of the 6G definition in the 3GPP standardization group. And now, I mean, there are studies that are going to be launched in order to define what are the attributes of 6G, what are the technologies, what do we do with it. And in particular, something that is important when you are thinking about terrestrial and non-terrestrial is the radio access network layer. And for that, we decided to set up, already in 2022, we launched an initiative to launch into space a laboratory for experimentation and early testing of 6G proposals, for this, to put at the service of the broader ecosystem, and to be able to test in a realistic environment what would be the ideas about these unified waveforms or unified protocols that would be seamlessly connecting terrestrial and non-terrestrial networks. When I proposed that, I was told, you cannot do that. Why not? Because they said 6G is not defined. How are you going to launch a satellite? And of course, I mean, for those of you that are more technically oriented, I mean, we go in the direction of software-defined everything. So we imagined a software-defined satellite payload. that could be programmable, and knowing key attributes like frequencies and so on and so forth, and a few other elements, we were able to engineer, to define a satellite architecture that is now being developed and is going to be launched in 6 months from now, something like that. This is something that the satellite is just one element of what I call the 6G Open Laboratory. And it is an open laboratory in a number of dimensions, including growth capability, and I will come in the next slide about that, is open for collaboration with people that are interested in that. And you see around this diagram some organizations that we are discussing with, and we are trying to set up a concrete collaboration to do engineering testing of ideas of this unified protocol and waveform into this laboratory that has some satellite elements there. So companies like Qualcomm, MediaTek, in the chipset side, infrastructure providers like Nokia, Ericsson, Samsung, some mobile network operators, some satellite network operators are invited to join this collaborative effort so that the communities expert in the terrestrial, cellular, and the satellite can work together and test the ideas. And inside this box, we have a number of collaborators, organizations that are coming and helping from the research side or from the advanced concepts, and they are putting some infrastructure to work on this open laboratory effort. And I added there test equipment providers with a very important role, because I mean these are organizations that are expert. They understand the terrestrial, they understand the satellite, and they are trusted organizations. As we believe that they might have in this open lab a key role in being trusted entities that would be the kind of, say, gatekeepers for competitors like Qualcomm and MediaTek to be providing their engineering ideas into a collaborative environment. Last but not least, I mean, we are setting up an agreement with the European Commission. There is a program called SNS, that is Smart Networks and Systems, I think, that is focused on 5G and the evolution of 5G into 6G. We are setting up an agreement so that this open laboratory infrastructure would also be available to SNS-funded projects. And we have already an agreement with one of them called 6G Sandbox, because the idea is not just to define protocols and the elements of the standardization, is also to test use cases. Imagine, I mean, we will have some infrastructure in orbit, and I will come with a couple of details in a second. We will have a number of satellites and access points through antennas on the ground that will be accessing this laboratory that is moving in orbit. Besides the technical engineering of definition of the standardization aspects, this is very useful to be connected with a number of test infrastructure that is being deployed worldwide to test use cases, including some of your domain in IoT, some in the broadband and so on. Different geographies, different vertical segments, and different vertical needs. I mean, just to give an example, the automotive sector is something that might be a key. And there are infrastructures for testing that are being deployed. What this open laboratory will offer is the possibility of adding the connection through a space into the mix. Okay, a bit of timing. We are intending to start this laboratory with maybe some initial elements that will not be optimized in the third quarter of this year. Towards the end of this year, we are hoping to have already some meaningful infrastructure to do testing, and this will run throughout 26, 27, and I think it will continue. If we are successful in attracting key players in the definition of 6G, but also key market players, I have no doubt that we will be able to continue investing into this infrastructure to create a minimum laboratory with a number of different satellites so that we maximize the chances of doing experimentation. And this is, of course, complemented with a number of what I call access points, ground stations that are connected to this infrastructure in space. I'm very fixated with the schedule because, and this is, I realize it's a bit too small, but I put there in contrast the timing of 3GPP. There is a period that I call good, open, collaborative engineering that is open since March this year until maybe around, if the estimates are correct about the timing of implementation of 6G definition in 3GPP, maybe end 2027. So this is a window of opportunity in which engineers from competing organizations might be willing to volunteer their ideas and to test ideas together between the terrestrial and the satellite world. After that, it becomes a bit of IP protection and trying to convey your ideas into the standard. But then this second phase of what I call the downstream of verticals, use cases, and so on, keeps on going. And of course, I mean, 3GPP works in releases. More or less every year there is a release. So the target for the launch of 6G is release 21. That is slated to be published or planned to be published 2029 for a starting rollout of networks for 6G in 2030 and beyond. There will be continuous evolutions, and there will be opportunities of doing further, more advanced experimentation. Let me now move into the topic of direct-to-device. That is a very prominent topic now in the market. And for me, as an old guy working in satellite communications, this is like we found the holy grail. We are still a niche sector or technology in the telecommunications spectrum of solutions, but something that has always been a big barrier for satellite connectivity is the need of having dedicated satellite terminals with parabolic or other antennas to connect to space. And of course, I mean, since we are niche, the volumes associated to the production of satellite terminals have always been relatively small compared with other technologies, which means that they are expensive. Now, the holy grail is that all of a sudden, if we are able to connect to this type of devices that are consuming devices directly from satellite, then we found a fantastic solution, what I call the holy grail. Now, it's always good to put a bit of a perspective. We are talking about billions of connections, maybe 63 billion connections, including IoT by 2029, 14 billion only in Europe. There is a dimension of the money somewhere that is talking about tens of billions of revenues, dominating in the regions of Asia and Middle East and Africa, because in Europe and let's say in the Americas, the connectivity is reasonable on the terrestrial side. Now, I always use an additional element of explanation there, because it's very nice what is happening now, and it comes in the next slide, with connecting consumers when we are hiking in the remote areas, that being able to send a message if we are in travel and so on. But the big dimension of this D2D is in the industrial IoT. I mean, in particular in the automotive sector. I mean, the future of connected cars to increase safety and going towards the autonomous cars is, I think, a fundamental thing, and let alone other means of transportation like autonomous planes, say drones, and autonomous vessels, ships. So it is a fundamental dimension. There are key things happening, and there is a race now that I think is illustrated in this slide, with the likes of Starlink already deploying part of their Starlink constellation with direct-to-device connectivity. They call it direct-to-cell. AST SpaceMobile launching large antennas into space, that provide the right gain in order to provide broadband connectivity to these devices, not just messaging, not just SMS, not just a voice call, a real broadband. This is a direction of flight. When we see companies like Apple investing significantly, I mean, Apple is basically, I mean, in that domain, is a device manufacturer. They want to sell iPhones and iPads. The fact that they are investing in satellite infrastructure is very significant from my perspective. And in China, many things happening. I mentioned a few examples, and there are many more. And this is mainstream in China. Constellations, geostationary satellites providing solutions today, but also low Earth orbit constellations being deployed with a lot of investment in production means. I mentioned that I work for the European Space Agency. We are an innovation agency. We focus on the technology. We see that there are some critical enablers. We can provide voice connectivity. We can provide emergency messages easily. The future is the broadband seamless connectivity while we are on the move. And for that, I mean, this is just a concept, an illustration of a massive array of satellites that are cooperating, and they might be connected, or they might be just wireless interconnected between them, that form a very large antenna, square kilometers of surface even, that is providing the right antenna gain so that we can provide the broadband to these small devices that we have in IoT applications, in our pockets, or in our vehicles. So this is what we are investing into as an element of technology development. And as I mentioned, our focus from the European Space Agency is through open standards. 3GPP is our standardization group, is the one defining the 4G, 5G, 6G, and this is what we are pushing towards. And of course, the seamless integration with the terrestrial. I mean, I showed in an earlier slide this big cube. This is the mainstream that we are into. And therefore, I mean, we have to play by the rules of the mainstream. We are now, I mean, translating that into concrete programs and initiatives, some that are proposed by industrial players to deploy constellations for direct-to-device with a target of being in the market with early services in 2028. We have in parallel are thinking about these more critical technologies that require a bit more maturity, longer term, so that in the 2030s, the advanced concepts with these, massive arrays of satellites can be deployed. And maybe there is a dimension also of more governmental institutional services. I can imagine that when we have firemen that are deployed, having a device that allows them to be connected anytime to receive the situational information that is allowing them to manage better the disaster that they are confronted with, or even in the case of safety, in the case of an emergency, that they can be located and can be evacuated, is something that is saving lives potentially. So, I mean, this is a dimension that is much more than just connecting the devices into our pockets for us consumers. I mentioned that I would very briefly, and I'm hoping that there will be some few minutes for questions, in case there are questions from the audience. But I mentioned that optical is something that we have been investing into since the early 2000s. That was in the infancy of optical communications. Now it is much more mature, and we are moving from the pure classical optical connectivity between satellites and Earth into something that goes into quantum. There is an application of security that is quantum key distribution. That is one of the dimensions of protection against the post-quantum threats associated to quantum computers. And we are in that avenue roadmap. I'm talking about 2040s. We are thinking about the evolution towards the Internet of the quantum things. So I mean, here, maybe in 10 years from now, this conference, this congress, will be having a stream on the Internet of the Quantum Things. No? So we are preparing for that already from today. Because, I mean, there are already some metropolitan quantum networks using optical fiber. There is a limit in the distribution of quantum properties in fiber. So there is a maximum distance that can be covered through these metropolitan networks. And imagining the same that happened with the internet that we know today, that started just by interconnecting computers together to increase their resilience, I cannot help but think that there will be a need of interconnecting these metropolitan quantum networks on a global scale. And for that, satellites are fundamental. Without satellites, you cannot achieve that. No, it is impossible to do otherwise. So we are preparing for, in the 40s, when this technology will be ready for the prime time, to have the solutions already qualified for the satellites to contribute to the interconnection of these metropolitan networks. And just the last slide is just, I mean, even I take the liberty of taking you into the 2050s. No? And I said I would take you to space. This is something that we are already investing into with optical communications and also radio frequency communications. When we are looking into exploration, now we have an initiative and we are deploying infrastructure to provide connectivity and navigation in the lunar orbit, around the moon. And now, if you think about 2 decades from now, we will be in Mars, and maybe asteroids, mining, and so on and so forth. There will be a need of a basic connectivity infrastructure and services. There will be a role for the Internet of Things, obviously a lot of, say, robotic operations. So we are imagining and we are investing into a network that connects at the solar system kind of level, utilizing, instead of base stations in the vicinity, relay stations in some of the convenient points in the distribution between Earth, the Moon, Mars, and other planets and asteroids. So I mean, just I wanted to finish with a lighter note of saying, even if you want something that is almost science fiction, we are already investing into that. With that, I see that we have a few minutes, so I would like to finish the presentation and maybe, give the opportunity in case there would be questions from the audience. I imagine that there are microphones, because otherwise I would not be able to hear the question. So, thank you very much for your attention, and then we open for a few questions. Thank you.
Hello, good morning, good afternoon. First of all, thank you very much for the presentation. Before asking my question, I would like to make one comment. I really love this kind of futuristic presentations, you know, because from someone who is, let's say, in the daily business, we look at it as a kind of, those guys who are presenting are at least dreamers or sometimes crazy. And please take this crazy as a positive one, because in this world we need some crazy people to disrupt the way how we are doing things. So I remember in 2006, I was attending a conference, and it was a consulting company, I forgot the name. And the guy who was saying, in few years, you are going to scroll on your mobile in your toilet. You are going to be in the toilet and scroll and see news on your smartphone. So we are looking at them as crazy guys, but the reality is few years after it happened. So thank you very much for this, because it is opening kind of, let's say, a different way you are taking us a bit in the future, but it opens new horizons, let's say. So my question, in fact, here is about, I see a lot of investment there, in fact. So this is the business guy who is talking right now. So I see public funds from ESA. MNOs, I'm coming from an MNO, so MNOs, they invested a lot in 5G. They are going to invest in 6G also. And I guess that we are expecting some ROI from it, for sure. So from your perspective as an expert, what will drive, in fact, this ROI in the future to get some money back from this? Is it IoT? Is it direct-to-device? What will drive the value to have this mass adoption in the future?
Yeah, that's a fantastic question. Thank you very much for it, and thank you for also, showing that you are coming from the MNO perspective. Because with the MNOs, I'm having serious difficulties because this monetization is normally focused on the today business. And my answer to your question is the answer is coming from the digitalization of businesses in particular. I will just give an example. No? That is mobility. Take logistics, transportation of goods. We have the means of connecting packages, goods, containers, and so on. But because of a lack of a unified network solution, you get islands that are controlling. So in a ship, you might have connectivity provided by the ship provider. You might have in the harbor some connectivity. You might have some connectivity on the move. Now, what is adding value, not just to you as an operator, but to your customers, the verticals, will be to have a seamless connectivity of, let's say, a container or the goods inside a container, no matter what the means of transportation is being used, air, ground, rail, sea. Because that is opening new avenues for the control of goods. Valuable, perishable, things that have to be tracked because they are critical, safety, security, you name it. There are a number of attributes. This seamless connectivity is what is the driver that I think will be a source of return on investment for those that invest into that unified kind of network. That doesn't mean that you as an MNO will have to invest in all the means. You are investing in something that is seamlessly connected with the networks of others. And this network of networks is what you are adding, what you are offering to your users that I think is very valuable. And I mentioned another one that is the autonomous vehicles. Autonomous vehicles will require seamless connectivity. Highways are now connected in many of our countries. And even there are gaps. But okay, that's a reality of the networks. When we go into autonomous driving, we will have to guarantee safety, not just on the main highways, but everywhere. In the narrow roads, on the mountain areas, and so on. For that, for you as a mobile network operator, it is not economically viable to invest into deploying infrastructure. And there is where having a seamless connectivity with what I call the 3D network layers that are above you is what guarantees this level of connectivity. I will leave it there. I could go forever on that topic. Thank you. Any other questions? We have still 5-6 minutes, please.
So I have a question as well. Do you believe one day it will be possible to communicate outside of the solar system?
Outside of the solar system, it is possible to communicate outside of the solar system. We have some probes that were launched in the 70s that are outside of the solar system, and they are still sending information to Earth. The question is, with whom and to do what? So it is possible, it just takes a long time.
Thank you.
Yeah, welcome. Any other questions? Doesn't look like? Oh yeah, here, there is one. And I think we are still okay in terms of time. We have kind of, say, 5 minutes.
Hello there. So my question is, speaking of interplanetary or interstellar communication, how do we reduce latency?
Reducing latency. I'm not a physicist. I'm an engineer, and so I'm based on the technology that we know of. So what we are doing is not trying to break the physical properties, but rather when setting the networks in a delay-tolerant way. And there are efforts already for decades of agencies like ESA, NASA, and others that go in that direction of coping with that. I always say, and people say, when I started pitching 5G satellite, they said, no, satellites don't fit in 5G. I said, why not? No, because there is a requirement of maximum latency that you cannot provide. And then I said, can I challenge the requirement? Because, if you have the choice, and they were giving the example of some remote surgery, somebody that is operating a robot from a distance. For that, the life of the patient is at risk, so then the latency is paramount. You have to get the minimum latency. And I said, yeah, we have astronauts that are in space, and in years from now, they will be on the moon, they will be in Mars. If you have an accident and you have an astronaut that has a life-threatening situation, what would you do? Let him die because your network has latency, or you would try to do everything possible to save the life, even if it means moving very slowly because you have some latency that might be seconds or even minutes. That, together with intelligence, local intelligence, if possible, human intelligence, but if not artificial intelligence, is what you do. So, I don't think that we can break the laws of physics. Maybe there are some. I'm a Star Trekker, no? And I have seen fast. I was inspired as a kid, as a teenager, by what I saw there. I don't see it yet possible. And yet, by working on delay-tolerant networks, we are able to cope with the situation of the physical distance. I hope that answered your question a bit. Cheers. So I see this in yellow. Any last-minute intervention? Last moment? No? Then I propose that we close here then the session. Thank you very much for your attention. And thank you very much for the interaction, the questions. It was very exciting for me to be presented here. Thank you.